Hello everyone, this is Anne from the Masquerade team. Joining in later will be Neha, Derek, Aruna, and CJ. Today we will be talking through our target market and value propositions, as well as our key features, and finally some insight into our plan for implementation. For now, I will briefly review our target market and value propositions. Our target market, to remind everyone, is any organization in need of facial reconstruction software, including but not limited to government agencies such as the Department of Defense, law enforcement agencies such as the FBI, and many others. Our first and most important value proposition that sets us apart from the rest is that Masquerade will be able to not only recognize faces, but also re-image a face with coverings. Our second value proposition is the fact that Masquerade will be an easy-to-use web app that many users can access and utilize within an organization. Finally, Masquerade will allow customization based on the specific organization's database, providing more accurate predictions.
As everyone knows, COVID-19 has given all of us countless problems, but more importantly, it has forced a new normal upon us. Part of this new lifestyle we must live is wearing a mask when going out into public. Although this does keep us a little more safe, it also presents us with a whole new problem. As you can see in this crowd of people, everyone now hides their identity behind a mask. Hiding these key facial features makes existing facial recognition software much less accurate and even sometimes not work at all. This presents a huge problem because of how much we rely on facial recognition today, whether it be to prevent crimes, find missing persons, aid in forensic investigations, and even help diagnose diseases. Facial recognition is used in a wide array of industries and markets, so our new normal of wearing masks can negatively affect anyone. So what's the solution? Masquerade, where we ask AI what these people would look like. For Masquerade to be as accurate as possible, we must first build and train a model of people with similarities to our unknown entity. This can be done within any organization by first training a custom prediction model to the organization's existing database. For example, if Masquerade is being used to help prevent crime in a local town, the local police department could use their criminal database to train the most likely prediction model. From there, they could input any image captured where the unknown entity has a mask or other partial face coverings, and Masquerade will then generate a new image of what that person would look like underneath those hidden facial features. The goal here is to produce an image that is most likely to return a successful result to any existing facial recognition software. Or, even better, if the generated image is a near match to the database that Masquerade was trained on, the person will then be found.
Hello everyone, this is Neha, and I welcome all of you to Masquerade. I want to talk about one of the interesting features of Masquerade. It is designed in such a way that it can extract a feature of the provided input image which is partially covered or distorted and will apply the facial re-imaging algorithm to construct an identifiable full face. Those areas of the face which is visible will remain untouched by Masquerade, and it will be used to complete the face which is completely visible. Masquerade is strongly capable to provide an organization as a service, which will allow an organization to ignore the cost to do the complete research and how to get platform as a service to integrate with the software that they have to develop to re-image or reconstruct a face. There is a lot of research that has been done for the facial reconstruction or using a GAN, which is Generative Adversarial Networks, but there is none of the software or service which is available to users. But I proudly conclude that Masquerade is something which has evolved to make it possible. Now Derek will discuss more about on its features. Thank you.
Thank you, Neha. Hello, everyone. This is Derek, and I will be going over our second key feature, the web application. Our team found it important to turn Masquerade into a web application because we wanted to provide our users the ability to have a 24/7 access to a service that allows multiple users from within their organization to use facial reconstruction. This will increase the workflow of these organizations because all the users can use the same custom facial reimaging model, meaning that each user will not be required to generate a new model each time they use this service. Likewise, having Masquerade as a web service also allows multiple organizations to use our service at the same time. As Masquerade grows, it is imperative that we have high scalability to store our training data. Using a web application gives us this ability because the data can now be passed to the Masquerade servers and stored on our internal database. An added benefit to this is as we collect more and more data, our general facial reimaging model will become more accurate and reliable. Therefore, this general model will be constantly updating, but because Masquerade is a web service, the most up-to-date model will always be accessible to our users with no need to manually update because they can simply access this model through our API. The easy-to-use web application that you can see here allows the user to import the training dataset if needed, and then import the image that needs facial reconstruction before generating a result. All the work is done on the Masquerade servers, which means the service is usable by anyone. Since there are no technical dependencies required for the user's machines, this greatly decreases security risks. Having Masquerade as a web application increases user workflow, generates a more accurate and reliable model, and gives our users the peace of mind that their data is secured. Its simple interface with no technical dependencies makes it a plug-and-play solution for any organization. Masquerade is only going to get better as we grow our database, and to tell you more about this, Aruna will be explaining our custom databases.
Thanks, Derek. Hi everyone, this is Aruna. Coming to the next key feature, which is custom database, the biggest hurdle for all the facial recognition applications that are there currently is the lack of sufficient amount of data to train the model. Moreover, most of the existing models are trained on celebrities. However, the average person does not look very similar to them. Masquerade aims to overcome this issue by allowing the user to select a custom database as shown in the image to train the reimaging model, which yields more accurate results. For example, if Masquerade was used in any of the police stations, the police department could input their own local criminal database. This would then generate a new model on faces that are all from the same location, as well as having similar key facial features such as face tattoos, which would generate better results if the input image is of an unknown criminal in the area. With the main goal of Masquerade to generate the best guess image of an unknown person, it's best to train the model on people that are more likely to look similar to the person. This separate database is what will be used if the organization using this application is unable to provide their own database. As Masquerade grows, the accuracy will grow more and more because more data will be accessible for training. CJ will be continuing the next slide. Thank you.
Thank you, Aruna. Hi, this is Chandan Kumar Patel, and I'll be talking about the current status of the project. So previously, we have shown you the implementation plan, that is how we are going to work with the project. And as it is displayed over here, we were sticking to it very perfectly, and hence we were able to finish the project well within the time frame in a very planned manner. And let me give you a quick demonstration of our application Masquerade. So to run the application, we use the command yarn run dev. And when we hit this command, we are directed to the local server at 3002. That's the port number where our application is running. It's taking a slight time to come up with. But bear with me, the application will be loaded soon. Yes, so here is the application. Now let me give you a quick view of the interface. This is Masquerade, our logo. We have implemented 3 algorithms: LBHP, agent vectors, and features. So you can select the algorithm which you want to apply. Import image. So this is the button using which you can select an image containing the masked face. And import database. So this is the button using which you can refer to a dataset containing images for the training purpose, training to the AI model. All right, so let me start the demonstration with this. Let me go over here and select one image. So I'm selecting this image. LBHP is the algorithm selected by default. And now let me select a dataset for the training purpose. So I'll go to desktop and let me select this directory. So it's asking me upload 183 files to this site. I'll say upload. You can see it's being uploaded here. So basically it is telling me that we are using 183 images for the training purpose, using which the AI will be trained. Alright, so now we start generate. So now the algorithm is called and it's working on the image and it's trying to match the image with a specified level of confidence. Now we can see here that the image in the question, the test image, we can see that only eyes and the stem is visible. The rest of the facial features are hidden. And the application could find it out as Boris Johnson, the Prime Minister of UK. So that happens to be a perfect match. Let me give you another illustration. So refresh and import image, go to desktop. Let me go to my presentation directory, 1.1 LBPH, and this time let me select something else, say this image. All right, and let me call the testing. See, once we have selected the image, once we have given the dataset for training, we need not to give the training dataset again. That will be used till we quit the application. In this image, we can see that the face is covered and this lady happens to be Kamala Harris. Yes, definitely, and it's a perfect match. And you can see that we can see only the eyes, eyebrow, and part of the forehead. The rest of the features are hidden. So it's a typical difficult image. All right, now let me give you one more illustration. So I will refresh it, go to select an image, and let me select this image. All right, so let's call the generate image button so it will start processing. In the meantime, let me tell you what happens. In this image, we can see basically three faces. One face is closer to the screen, closer to the camera, and there are two faces in the background, but still they are the faces and application can identify them. In fact, the application has identified the face behind the COVID mask as Mike Pence, the Vice President of the United States. Okay, this application with a little modification can be trained to identify up to three faces from a given scene. But right now, for a demonstration, I am showing you only one. All right, so why not to try with another algorithm. Refresh. Let me import another image. Instead of LBHP, I'll go and I will go to Egen. And here, let me select this image. Okay, and this time I will select Egen vectors. And let me say generate image. Again, you can see this image is a close-up image, different than the others which we saw previously, and only eyes are visible, root of the nose is visible, and forehead. And using these features, we are identifying this image to be our President Donald Trump. So basically, you can see that majority of the facial features, like the shape of the nose, the lips, the cheeks, and the cut of cheeks, the chin, all these things are hidden because of the COVID mask. And still our application is able to identify this person perfectly. Let me give you one more example, the ability of our application. So let's select this image and select Egen vectors and let me start generate image. We can see that in this image, the speciality is that the background and the hair, they are merging like one thing only. And for application, it becomes really difficult to identify the face, separating it from the background. Still, our application could identify this person as Justin Trudeau, the Prime Minister of Canada. All right, so this gives a fairly good view of our application. At academic level, I will say this application is working very nice. We tried with couple of images and we are getting a perfect result. There is only one limitation, and it is that because we are running this application not on a server but on my local machine, and this MacBook is having a memory of only 16 gigs. So I need to be contented with 183 images which I used for the training. If I have got a bigger machine, or if I have got access to a server, then I can definitely go for training with a larger number of datasets, the thousands of them, and that definitely will give me a very accurate model. But still, at academic level, this accuracy and this presentation, I think it really makes a good sense. We have also tested this application uh, as a distributed application using another application using Postman for inputting the things on the various endpoints, I mean the API endpoints, and they showed the perfect result. It's working very perfectly. Also, I would like to say the success of this application is definitely to be attributed to all of my team members whose hard work you can see on the screen. So everybody has really contributed a great effort in this application, from testing of for testing purpose, for generating the GUI, and checking the code and all these facts. So I would like to say that the credit goes to all of my team members. Thank you very much.
Thank you, CJ. Now, as you can see from our current demo, as of right now, we're just returning a classified result from our training data. This is a very important step because from this classified image, we then need to extract the facial features and map them appropriately onto our input image. This step is what separates Masquerade from all the other existing facial recognition softwares out there. What makes this step so special is even if the classified image is not an exact result of the person in the input image, their facial features can still be extracted and mapped to give the best guess of what the input image really looks like without a mask on. We will need to do more research and development to take these extracted features and apply the appropriate color correction and transformations to produce a realistic resulting image. Now, Aruna will discuss our business model. Thank you.
Hi everyone, this is Aruna and I will be discussing the business model of our product. Coming to the first component, our key partners include cloud computing service providers like Amazon Web Services. And we will be building an accurate facial reconstruction app, and the key activities include research and development, marketing of the application, and custom database model training. The most important key resources needed to make our business model work include machine learning algorithms, neural networks, deep learning, web interface, and the team of our developers. Our product reconstructs the face with highest probability on any image with missing features. We'll be able to generate prediction models customizable to any organization's existing database. Due to these value propositions, customers turn to our product. And coming to the customer relationships, it is highly scalable, as in it can able to handle a large increase in users or workload, and easily accessible, and without any personal assistance customers can use it, and it can be customizable to any organization's data. Coming to the channels, our product communicates and reaches its customers via Masquerade web application, custom API, GitHub, and social media. The potential customers to our product include all companies that rely on facial recognition like security, medical, education, etc. The most important expenses include high cost of the algorithm and its complex architecture development, continuous research and innovation since facial reconstruction is something brand new, and hosting of the web service. Our product will be provided to the users for a subscription fees, either a monthly or yearly. Also, we are going to charge one-time fee to any organization to build a custom prediction model on the current database to provide better results. And machine learning as a service, which provides machine learning tools as part of cloud computing services. Basically, this helps clients benefit from machine learning without establishing an in-house internal machine learning team. Coming to the statistics and expected growth, entire facial recognition market is growing to have $7 billion by 2022. So our product is estimated to reach this entire market at 5% by year 1 and 15% by year 3. Yearly subscription cost may range between $50 to $5,000 depending on the customers. And our product is projected to gross $1 million by year 1 and $5 million by year 3. Yeah, so that's all about the business model of our product and expected growth in the next 3 years. Thank you.
Hello everyone, this is Neha, and I will be highlighting the contributions of all of our co founders of Masquerade. Derek. He is the root of Masquerade who brought the idea and finally made it successful. He worked upon the web application development part. Next is CJ. He is the one who took care of the AI development branch of Masquerade by implementing OpenCV algorithm for facial recognition and worked upon the GUI part as well along with Derek. Next is myself, Neha. I worked upon the market research to understand the value propositions and target market, and also on knowing our competitors so that we can make Masquerade and unique in the target market. I also worked upon the MongoDB setup for Masquerade. And then Aruna. She did market research on how to make Masquerade a hit in the market by overcoming the defects present in the present market products. She prepared the documentation on Masquerade and arranged the dataset and trained the model. Last is Anne. She contributed herself in testing the web app along with designing the system architecture. She created the implementation plan and phases of release for Masquerade. Thank you.
Hey all, this is Anne here. The Masquerade team is still in search of several things to help us continue to develop and expand our reach. The first of these is a grant from the DoD, which would greatly help us further develop and maintain Masquerade. Masquerade would still benefit greatly from a supercomputer as well, which would allow for faster API calls on our backend. Masquerade would love to get some more large data sets as well to continue to train the AI. Further, one additional thing we could really use is a marketing manager to ensure all of our potential customers are able to fully understand what Masquerade can offer them. With more customers using our app, we would then in turn be able to gather more data, making Masquerade even more accurate. With that, we conclude our Masquerade presentation. Thank you all for listening.